more involved sections, like we're going to draw on a lot of ideas that we've already developed. And it's kind of important that we really have a good idea of what's going on. So in section 7, we're going to be talking about three-dimensional vector line equations. So if you guys remember from before, our general form for a vector line equation was this, where the vector r is equal to the vector r naught plus the vector v times t, where just t is some scalar. Remember, we said that r naught is our point vector, and our vector v is our direction vector. Now, the place where things get a little bit weird in 3 dimensions is, what the heck does a direction vector mean in 3 dimensions? In 2 dimensions, we just used slope as our proxy for the direction vector, and it was an easy conversion. Remind me again, how do we calculate slope? Yeah, it's like the change in y over change in x. So specifically, what do we need to calculate the slope? 2 points. So let's say that we have 2 points. That are in 3-dimensional space. So remember, these are x, y, z's. Slope doesn't make sense, but if we think about this in kind of like in general, let's just say in general, if we have 2 points, that would represent a direction that the line is going, correct? Or that would represent the direction that the line is going. Everybody okay with that? So really, when we create this direction vector, all we're doing is just a head minus tail rule will create a direction vector for us. Everybody agree with that? Now, does it matter which one I choose as the head or the tail? Nah, it doesn't. If both the red arrow and the blue arrow that we drew are both valid direction vectors for our line, that doesn't matter which one I make the head and which one I make the tail, right? In general, for me, because I'm stupid, I would mess things up. I would just take the first one and subtract from the second one, so I don't have to worry about like doing anything goofy. But I would just say that my direction vector then is just this 8, -6, 5. So if I wanted to write the vector line equation here, I can use either point as my point vector. It doesn't matter. For the sake of argument, I'm just going to use the first one. And then a direction vector. So I did my head minus tail rule as I shown above. And it doesn't matter which one you make the head and which one you make the tail. And then I'm done. Is everybody okay with that idea? So again, direction vector, not slope anymore, but given the same inputs, a pair of points that we would need to calculate a slope, we can calculate a direction vector just as easily. What turns out to be quite a bit more challenging and something that we're not going to do is to take this vector equation for a line and write it in like our standard form with like an x, y, z variable. We're not going to do that in this class. But one of the nice things about these vector line equations is it's really easy to write a three-dimensional equation for a line, and it's not very easy to do that in kind of our standard representation. Is that okay? All right. So let's then check to see if I give you a point, if we can determine if that point lies on a line So if I want to check to see if the point -5, 6, 11 lies on the line -3, 12, 7 plus 1, 3, -2t. We already did this in 2 dimensions, right? This was a kind of a question we already did with 2 dimensions. Do you remember what we did? We just plug in our new point vector for r and see if there's a single t that allows this to be true. So basically we just check, we write 3 equations, and solve each of the 3 equations for t, and check to see if we get the same value for t each time. If we get the same value for t every time, then we know that yes, that point does lie on the line. If one of the values of t is not the same, well, maybe I should say at least one of the values of t is not the same, then we know it doesn't. So in this case, the value of -2 for t does generate the point that we're interested in. So absolutely that point lies on our line. It's the same process as 2 dimensions. We just have 3 equations to check rather than 2, but it's not that big of a deal. Cool? Okay. So 8, 7, not really a big deal, right? It's just still kind of the same ideas as what we're doing in 2 dimensions. We've just extended things out to 3. The only thing that's kind of sneaky was this new way of finding a direction vector, but it's just using an old method, right? So, I mean, that's new, but not difficult. So in section 8.8, we're going to talk about intersections of 3-dimensional objects, and we now only are going to talk about the intersection of lines and lines in 3 dimensions. Previously, we talked about planes and planes, or planes and lines in 3 dimensions. We've pared this down to where we're just going to talk about the intersection of lines with lines. So there's 4 possible outcomes here. So we can have 2 lines in 3 dimensions can intersect at a single point. Not surprising. They can intersect at every point, i.e. the lines are coinciding, like they're the same line. I think in your Algebra 3-4 class we call this the infinitely many solutions situation. Now the last two outcomes are actually both no solution situations. So one is where the lines are parallel. And the fourth situation is we can have lines that are non-parallel and non-intersecting. And you might think about, like, Mr. Kulik, how in the world is that kind of a thing possible? Okay, come on, OneNote. Don't be stubborn. So just to give you an idea, so say that we have two lines. One line is in this plane here, and the other line is in this plane here. Clearly, these two lines aren't parallel because there's not a single plane that captures both lines. Everybody agree with that? But they're also not intersecting at all either because they're in two separate planes and they're contained wholly in those two separate planes. Does that feel okay there? So there's actually four different outcomes we can have. Okay there? All right. So what I'm going to do now is I'm going to build like a little bit of a flow chart for you guys so you can see how we go about doing this, or how we go about checking this. I'm actually going to steal the flow chart from my other set of notes because I don't want to draw it again. Okay. So I'll be right back. Oops, wrong class. This one, content library. Go down here. Oop. Drop you in. Okay. So I'm just going to kind of talk through this while you guys have a chance to write if you're copying things down. And obviously you don't need to because it's all in the content library if you prefer. So I have the two lines here that I'm going to be talking about are just going to be R1 and R2. So remember the point vector for R1 I'm going to call R0, comma 1. And the direction vector for R1 I'm going to call V1. And the point vector for R2 I'm going to call R02. And the direction vector is going to be V2. Everybody's okay with that notation? So the first thing I want to do is I want to check to see if the lines are parallel. And to do that, all I need to do is check the direction vectors and see if one direction vector is a scalar multiple of the other one. So basically, is there a k that I can multiply one direction vector by so that it's equal to the other direction vector? Now that's a really easy check to make. If the two lines are parallel, the next thing I'm going to check to see is if they are coinciding. To do that, I want to check to see if the point vector from one line is on the other line. So I can take the point vector from R1 and check to see if it's on R2, or I could do the reverse. I could check the point vector from R2 and see if it's on R1. It's doing the same thing. If they're coinciding lines, the answers to both of those would be yes. And if they're not coinciding, the answers to both of those would be no. So again, if they're coinciding, we know that. If they're not coinciding, I know that they're parallel. Now, if the lines were not parallel, the thing that I would do next is check to see if they're intersecting. To do that, I'm going to check to see if R1 can ever equal R2. And this is the same process we used in the two-dimensional situation to find the intersection of two lines. We have an additional equation, so there's like one extra thing we have to do there, but it's the same initial setup. If there is an intersection, then we would want to find that point and list it. If there is no intersection, then we know that the lines are non-parallel and non-intersecting. Bless you. Sure. Does everybody feel okay on kind of how we're reading this flow chart? Again, it's not so bad. There's only 4 outcomes. So there's only 3 tests, and all the tests are kind of things that we've done before. You guys ready to go move on to some examples, or do you still need a minute? Was that need a minute? Okay, I just heard a bunch of grumbling. I wasn't really sure what we were grumbling about, but if you would like a minute, we can take a minute. No big deal. This is the last topic here that we're going to talk about in Chapter 8, is this interaction between 2 lines in 3 dimensions. You guys missed all the fun stuff, which was all the plane stuff that this used to be 2 separate chapters. What is now Chapter 8. And there's a whole bunch more stuff about the interaction of planes and writing the standard form equation for a plane and the vector equation for a plane, and a whole bunch of fun stuff that we don't do anymore. If you take Calc 3 in college, you'll probably do a lot of it there.
I was going to say, my brother said that this was going to get something that help looking for that. I think we did that.
Yeah, we don't go that far anymore. We used to. Okay. We good to do some example in here? All right. So I'm just going to write down the equations for the lines. The direction would be like determine the relationship for the lines, and if there's an intersection, to find that point of intersection. Okay, so here's our equations for R1 and R2. According to the flow chart, what's the first thing I'd want to do here? See if they're parallel. Great. And how do I do that?
Any k value to make
Yeah, so I'm going to compare the two direction vectors. And see if I can if there's a k that I can multiply the one direction vector by to make it equal to the other direction vector. Now, in this case, you can probably do this on site, right? Are these two parallel? Yes. Why? If k equals -4, then the equation is equal, right? Everybody can see that? Now you have to check every component, but it's not too hard to do. Some of them, if there's like a fraction involved, though, can be kind of tricky to see. For example, if k was like 5/3 or something, you know, Mr. Coolett can be sneaky and give you something that's like tough to see on site that like, oh yeah, that does work. So don't be like, I looked at it, doesn't seem like it works. You could have fractions, you could have weird things. Mr. Coolett's pretty sneaky. Make sure that you're really checking. Okay. But we know they're parallel. So what do we do then? What do we need to check now that we know they're parallel? Okay, great. So let's see if they're coinciding. And how do I do that? Yeah, I want to see if there's a point from R1 that's also on R2, or vice versa, if there's a point from R2 that's also on R1. So what I'm going to do is I'm going to see is the point 2, 3, 3 also point on R2. And again, this is exactly like what we just did in the last example, right? So I'm just going to see, is there a single S that satisfies all of these equations? Oh, this was -4. I just copied it wrong. So I did get the same value for S every place, correct? What does that tell me then? Yeah, so these are coinciding, right? Because if the lines are parallel, and a point from the first line lies on the other line, well, they all have to lie on the, they all have to be the same line, right? Does that feel okay? Now, what tends to be the trickiest part for students is just kind of making sure they have these tests squared away and they know what they mean. Because again, they all feel kind of the same, right? If you don't really understand what it is you're doing, if you're just like punching numbers and plugging numbers through it, kind of they all feel the same. It's just kind of like checking to see if something is equal or not. Let's do another example. So here again, we have two lines. We want to figure out what's going on between them. You know, are they intersecting, parallel, coinciding, non-parallel, non-intersecting? What's going on? Okay, so what's the first thing we should check? They're parallel. And how do I check if they're parallel? Yeah, we compare the direction vectors. So let's see, here k would have to be negative 2/3. Here k would have to be negative 5/9. And already I can stop at that point, right? I don't care what the third k would have to be. Maybe I should call this like kx, ky. Maybe that makes it a little bit clearer what I'm doing. But whatever, right? Point of the matter is they're not parallel. Everybody agree? Again, you might have been able to do that on inspection. Not unreasonable. Okay, so what do I check then if they're not parallel? Do they intersect? And how do I do that? I set the two lines equal to one another, right? So this was just like what we did with 2 dimensions. Everybody's okay with my initial setup here? Do you remember what we did in 2 dimensions after this point when we set the two equations equal to each other?
We had all the x's and then like systems of equations.
Yeah, so we do the vector operations to get each side down to a single vector. So like the first, or the left-hand side becomes 2 plus 4t, then 4 plus 5t, and then 1 minus 3t. And same thing on the other side. And now we know if these two vectors are equal, the components have to be equal at the same time. So that creates like a system of equations. Everybody's okay with that? And I'm going to just move these over so that it's kind of in that standard linear form. Everybody feel okay with what I've done there? Does it matter whether I wrote the S's first or the T's first in my standard form? Not really, right? Not really. Okay. Look at this system, though. Do you notice something unusual? How many variables do we have in our system? 2. How many equations do we have? Is that too many equations? Yeah, right? We only need 2 equations to solve 2 variables. So I'm only going to bother with the first two equations, that's actually the system I'm going to solve. So remember, to solve this system, we're going to use our calculator to create a matrix. Just to review how we do that again. So I go and at the home screen, I press second and the X to the -1 button to open the matrix menu. I'm going to go over to the edit tab, pick a matrix. I'm going to use matrix A. I'm going to enter in the entries of my matrix. So 4, 6, -4, 5, 9. Oops, I have those in the different order from when I did it last time, I guess. So 6, 4, -4, and then 9, 5, -8. It's fine. Everybody's okay with that? Once we've entered our matrix in, we exit back out. We go back to that matrix menu, but this time we're going to use the Math tab. From the Math tab, we'll scroll all the way down to the bottom till we find the RREF command. We press enter to select that. Let me go back to the matrix menu, select the matrix A that we just built, so that we're doing the RREF of matrix A. We'll press enter and we get this matrix here. The takeaway here is that the S is equal to -2 and the T is equal to +2. I know that this is the S column because we put the S's in the first column, or the S coefficients in the first column. This is the T column because we put the T coefficients in that column. Everybody's okay with that and how we're reading that? Okay. So now we just find our point of intersection, right? Not so fast. Remember the equation that we omitted? We still need our S and T to satisfy this equation as well. So I do need, before I move forward, to check to make sure that that third equation that we didn't use is satisfied. Since it is, I know that these two lines are intersecting. So that part's done. To find the point of intersection, then I'm going to pick either S or T. I'm going to use T because there's no negative sign in it. It makes it one less thing for Mr. Kulik to screw up. So if I plug that in, I have 2, 4, 1 plus 4, 5, -3 times 2. So that's going to give me 2 plus 8, so 10. 4 plus 10, that's 14. And 1 plus -6, that's -5. So that's my point vector, or equivalent to the point 10, 14, -5. Does that feel okay? Just as a heads up, in the situation where you have non-parallel, non-intersecting, one of two things could happen. You could get a system right here that has no solution, or when you go to check your answer, it doesn't check out. Either one of those would tell you that it's non-parallel, non-intersecting. Everybody's okay? All right. So we have decent chunk of time here. Let's do this with the remainder of the time. So let's look at our problem set. Let's look at the 119 through 122. Those are the last 4 problems on the problem set. Let's just have you guys, we'll work on those kind of one at a time. We'll take, 10 minutes or so and then kind of go through it. We'll just kind of bang through these one at a time with the time remaining. Get a little bit of extra practice in here on this and also knock out the hardest problems from the problem set at the same time. Feel like a good deal to you guys?
So we try to do it and then you'll
Yep.
over with us?
Yep. If you want to talk to your neighbor or whatever, feel free to collaborate. It's real informal, not a big deal. But I would, if I were you guys, whatever we don't finish on these 4 here today, I would definitely want to make sure I've at least done these before next class. Just saying. Just those 4 are the 4 that I would worry about, making sure that I've done before next class.
No, it's not long.
Oh, I knew there was going to be another.
Yeah.
I'm just, just in case.
Maybe I don't know. And maybe
Yeah, maybe you don't know, right?
Yeah, that would be kind of twisted. Actually, not really.
Would be a good way to get you to do the
Yeah, I was gonna
homework.
say, kind of smart.
Especially since this isn't on Sunday's problem set, this stuff. So while you guys are kind of picking away at this, I'm just going to say a couple of things about the remainder of the chapter and the schedule for the next week and whatever. Okay? Good. So Monday and Tuesday are just going to be kind of like catch up on your problem set days, since there's 122 problems and a worksheet and a review. It's a lot of stuff. Sunday's problem set is like 51 to 94. The next week's is 95 to 122 and the worksheet and the review. So Monday and Tuesday, A and B days, are just going to be like a general, get some work done day after we have a surprise. And then your review day we'll do on Wednesday and Thursday. So we'll have a chance to have big question answers, all that kind of jazz, and just get some work done. And then the A people take their test on Friday and the B people take their test the following Monday. Nice Valentine's Day surprise for the B class. It's because you're so in love with math, No? I thought it was cute.
So should we memorize the flowchart for the test? Would that probably not be for us?
Yeah, so on the test or whatever, I would not give you the the flow chart. I would not give you the little tests on what you need to do on the flow chart, because again, there's just 4 outcomes. There's 3 little tests to do. It's not so much, and it's not really any different than things that we have done elsewhere, right? Like checking if a point is on a line, or checking if 2 lines intersect, or these are all things that we've done as problems elsewhere. And I think if you think about that flow chart reasonably, it's like, well, of course these are the outcomes, and
Okay,
yeah, I think the answer key is the numbering's goofed up in there or something. I'll put that on to check what's going on there situation. But I think that was an issue in the past, and I'm not sure if it got resolved. Yeah, so what is the issue? There's something that's just not there. But 117, I think, is the answer for 119, and 119, I think, is the answer for 121. But I think there's something that's not. Oh, it's that there's two 115s. That's the issue. So that's all it is. There's just two 115s and it screwed up all the numbering. Yeah.
Oh wait, oh, never mind. Yeah.
Okay.
I was looking at the no side of the chart. Yeah, I got
Are we done with 119 and ready to talk about it, or do you need a minute? If you need a minute, somebody say something. If not, I'm just going to go. You need a minute? No problem. No problem. It just sounded like people were done. I didn't want to keep you waiting, but if people are working, do your work. It's not a rush. All we're doing is just going through stuff. I just don't want you to get bored sitting here waiting for me or whatever. I don't think so.
I feel that.
Yeah. And I appreciate it.
Okay, should you get a solution, then just stay first.
Yeah.
I don't think the first one is why did you not? I did. Right here. I mean, you didn't. Come on. I say this.
So 119. First thing we do is check to see if it's parallel. So it should be pretty easy to see that 6, 4, negative 8 is 2/3 of 9, 6, negative 12. So we know the lines are, or they have parallel direction vectors. Then we'll check to see if they're coinciding by taking the point vector from the first line and seeing if it's on the second line. To check that, I just see if to get the x, y, and z components, I need the same value for b. And it's pretty quick there that I can see that I need a different value of b to do that, which tells me that the point negative 3, 4, 2 does not lie on the second line, which means that these have to be strictly parallel and not coinciding. And again, you don't really need to get the 1/12 or negative 1/12. You don't have to do all of those. As soon as you get a pair of B's that don't agree, you could stop and just, because you know. Oh boy, we named these. I'm going to screw that up. Again, we'll give you guys some time. We'll talk about 120 here in a few minutes. Is that okay? All right. You know, just playing it cool. Just chilling. Checking out my Super Bowl prop bets and figuring out what I'm going to lose money on. I'm just joking. I don't gamble on sports.
Yeah.
Good call.
I'm not buying that.
You're not buying that?
You have to gamble on something.
I don't have enough disposable income to be gambling on things. I'd rather spend my money on sure things. The Gatorade color?
Yeah, you can gamble on the Gatorade. No way.
That's a traditional Super Bowl prop bet.
$500 on tails.
Yeah.
480 on heads. You gotta hedge yourself. Cut your losses.
What used to be
You win either way.
What used to be you got a real good number on was a safety being scored, but like the last 4 Super Bowls, like 2 of them have had safeties in them. They used to be like a, like 20-1 kind of number you'd get on that, where it's like you can put a small bet and win a bunch of money. But I'm assuming that odds aren't great on that, because I think Las Vegas lost a bunch of money here in the past 10 years with that bet, because there's been a lot of safeties recently.
I might bet the under safeties.
I don't know that is the one that exists there, Paul.
Betting those safeties.
Maybe you could get us great odds for first score being a safety.
Oh yeah, you can. I see. It's like plus 4,500 or something.
Yeah.
That might be.
That's a pretty good number if you want
But
to.
I don't think I'd ever miss that.
You don't-
The thing I found with the Bengals, I won a lot of money on this was over.
Burrow's been sacked a ton, and the Rams have a great pass
This
rush.
is true.
If you get like pin them back there, you'd definitely see a safety.
They kept putting the Bengals line at over 0.5 points for the first quarter. in the past 2 games. I mean, it's not that because they lost a bunch of money, but it was like literally, I swear, free money. Just hammer that over 0.5 points. Joe Shiesty never fails.
Joe.
All right. So 120, the first thing we'll do is we'll check to see if the 2 lines are parallel. And you can tell right away that they're not, since k has to be 0 in the y component, but clearly that doesn't work anywhere else. So we know the lines are not parallel. So this is the longest one, because we have to check then to see if the 2 lines intersect anywhere. So what do we have? 3 minus 2c, 8, 7 plus 1c, 9 plus 3d, negative 12 minus 5d equals 2 plus 3d. And this is a system I would probably just solve by hand because you have that value for d just staring at you. So right away you can tell d is negative 4. And with that, let's see, negative 4 times negative 3 is 12. Subtract that over is negative 6. Divide that. So c has to be 3. And then I'd have 3 plus 12 is not equal to negative 5. So I would say these are not intersecting. Because of that piece right there. Does that feel okay to you guys? Jack, what's up?
Would that be a positive 1c or negative? Yeah, I think it's negative 1c.
Oh. Okay. Well, I mean, oh, because I moved it over. No.
Yeah, I think they're.
Oh, positive 1c here. Yeah. Okay. But still, it doesn't. Oh. I think I just copied the negative sign in there wrong, but I put the positives in there everywhere else. I don't know. Anyways.
Yeah, I think.
I got there in a second. For the last,
This is 120.
that's what I have.
Did I goof it? I mean, it's possible.
It's a negative 7 and negative 1.
Yeah, that's what it is.
Where's the negative 7? Did I copy it down wrong?
Because that's what I have.
Oh, it sure is a negative. I did. Look at this.
Negative 3 and yes. Oh,
I copied it down wrong.
8, negative 10. Cash.
That's what I have to say to that. Fiddle poop. All right, well, let's see. 9. That should be negative. So yeah, it did work. Help if I copied the stupid thing down. What a Mr. Kulik mistake that is. You know? Okay. So we'd say intersecting at, I'll just use the value for C because last thing I need is another negative sign to goof up. What do I got here? 3 minus 6, 8 plus 0, negative 7 minus 3. You think that's right, my brainiacs? Oh, good. Jeepers creepers, Mr. K. Well, we have a good example of what no solution would look like, right? All you gotta do is drop those two negative signs out of there and you get a no solution one. I have to remember that when I have to make up some more problems.
Halfway.
Yeah, dude. I'll tell you what, I'm mad at whoever wrote this problem set and is using E as a variable letter.
Is it okay to switch that?
Yeah, it
I
is.
just
I mean,
switch everything back to T.
yeah, it's just a name, man. Why does Mr. Kulik hate using E as a variable name? Because there's also a number that's E that we call E, right? It's like, which E are you talking about? Is this a variable? Is this the 2.71 yada yada yada?
Same with like I.
Yeah,
I hate when
I don't have any I's as variables on this particular set.
people use O's. Or,
Oh, O is a nasty variable.
I think you did that to us once. Yeah.
Probably. I think if I was writing the O, I would put like the cursive O or something. Whenever I have to use the lowercase letter L, if you're doing like length times width, I always use the cursive L so that it doesn't turn into a 1 or something on me. But this is somebody that acknowledges their penmanship is like kind of crummy. I mean, it's not the worst penmanship in the world, but it ain't great. You know? Got to tell apart those 2's and Z's and the 7's and the S's and 5's are always a troublesome.
Q's always look like a Z too.
Yeah, I put those bars in. Got to put that bar in on the Z's. It's a lifesaver. But back in the day when I was doing geometry or whatever, it'd be a nightmare with the L's and stuff. I have to do cursive all the time. And people are like, "What's this? Why do I have to learn cursive? Like, who needs that?" It's like, yeah, like, it comes up,
I
man.
like writing cursive.
I hated it as a student, but like, I'm glad I know it.
Mina, did you win like the cursive handwriting?
No,
I thought you did.
that was not a thing.
It's the handwriting competition at St. Hugo.
Yeah, I had one of those at my
Like
school.
Dude.
first grade?
Yeah,
remember
you won
the
that.
thing, though. I had that in my
You 100% won
I
that.
did not.
It was either you or Maria Van Buren. I swear it was
That's all I
you.
need.
Oh, I do remember that. That was not me.
You definitely won.
It was definitely Maria.
Alright.
Ooh. Of course. All right, Mr. K, make sure you copy this down right before you get too far into this. Forgot to multiply by the 2. I just made it negative, I think. So there's 121. You guys feeling more comfortable after doing a couple of these? Hopefully it usually makes a big difference after just kind of running through the procedure a couple of times. Now, Mr. Kulik, take a minute and double check and make sure you copied it all right before you dive on in there and screw something else up. Yay, caramba. All right. The last one I got was non-parallel, non-intersecting. That feels pretty good, right? Yes, sir.